Hello everyone, welcome to another Geo Group Outlook. And this time it's for milestone 17.1. My name is Sampath Ranasinghe. I'm the product manager for the group. In this milestone, we're going to focus on two major features, unified backups and org mover. Let's dive a little bit deeper into unified backups. We've talked about this in the previous videos as well, and we've been working on this for a number of milestones. Unified backups essentially is our attempt to create a single solution that works across not only the different types of GitLab installations, Linux package, Docker, cloud native hybrid, source code, and GDK, but also we want it to power our SaaS solutions going forward as well. So that includes GitLab Dedicated and GitLab.com. This also gives us the opportunity to dog food our own backup solution. So some of those who are familiar with our current backup solution, there are a number of them. We have one at the GitLab Break Task for Linux package, backup utility for cloud native hybrid, and GitLab Dedicated and .com have their own unique backup solutions as well. So what we want to do is unify this, and by unifying it, it gives us the opportunity to dog food our own solution, but also it means us concentrating the development effort that gets multiplied across, and its impact is much broader by it catering for all the different offerings of GitLab and all the installation types. We also want to make this a solution scale. Acute pain point of the current solutions are that they don't scale for customers with large data sets. So this is also a key focus for us. So as the first iteration, we are trying to get a release out that focuses on 1K omnibus reference architecture with local storage. This helps us lay the foundation for the longer term solution. There's a bunch of refactoring that is being done by the team, and also looking at new technologies, new techniques that have evolved since the old backup solutions were built, that we can leverage to deliver a better user experience and higher performance. We were hoping to get this out in 16.0. However, we ran into some difficulties, some snags, I would say, with that release. So this is now rolling into 17.1, and we are optimistic we'll be able to get this out in 17.1. In parallel, the team have also started work on the next iteration, which is targeting cloud native hybrid architecture with the 10 and targeting a larger reference architecture, 10K reference architecture. We are so that effort also looks at supporting object storage as well, and we're targeting GCP as the first cloud hosted architecture. This is mainly driven by internal demand. We want to get it onto some of our internal systems, and GCP gives us the biggest bang for the buck. However, we will be extending this to AWS in the not too distant future. And also, as part of this effort, and to share how we're building it and what our long-term plans are for unified backups, we're also working on an architectural blueprint that can be shared with internal teams to help them understand how they engage with this backup and what it means to them, but also and that includes our infrastructure teams very importantly. And then also it gives that next level of detail for our customers if they're interested in how this solution is all going to come together. So quite exciting to have a single solution that we can iterate on and build new capabilities against to deliver better experiences for our customers and better outcomes. Next up is org mover, and a little bit of background with regard to the org mover is that GitLab current .com architecture is reaching its limits on how far it can scale. and we are looking at a next generation architecture based on what we call cells. Cells are essentially, we will be sharding GitLab.com into individual cells and spreading the load across a fleet of cells. So, quite naturally, we need to be able to move the customer's data from the current GitLab.com architecture onto cells, onto a cell to start with, and for that purpose, we are building the org mover. So organizations is also a paradigm that is closely connected with cells. A customer can choose to opt into an organization, and that helps them encapsulate their data and build a certain level of isolation around their organization's data. Around the organization, we will use that encapsulation to facilitate moving the organization from the current GitLab.com infrastructure onto a cell. And in order to be able to do that, especially for very large customers, we need to be able to do some of the copying in the background. Otherwise, the result will be that the customer needs to experience a very large downtime while we migrate their data. Geo team, having experience in replicating, or called continuous replication, is the team best placed to look at this, investigate how best to approach this. Geo already helps our customers fail over onto new infrastructure, and this is essentially the same process. So org mover, we will start with a high-level blueprint for org mover, and the idea would be we would copy an organization's data in the background while an organization is still live on current monolith on GitLab.com. It'll still be read and writable, that organization, but we will start to copy their data in the background over a period of time. And eventually, when we've caught up, when the destination cell has caught up with the data, we will perform a cutover where the organization will be stopped. The traffic for the organization will be switched from the current monolith to the cell where their data has been migrated to. There may be, at least for initially, there may be a small amount of downtime required while we perform the cutover. So we start off with the blueprint. So we've got two engineers working on the blueprint, and part of the blueprint work is to investigate the best technology to use for org mover to underpin that replication. And one of the key components we are looking at is Postgres replication. So I will come back to that, but I will talk about checksum of all data independent of geo first. We want to make sure that the data is copied from the source to the destination correctly, and the data integrity is preserved. So we use in geo, we use checksums to do that, and so we will also do similar thing for org mover. So we'll generate checksums on the .com side, on the source, and we will generate checksums on the destination side, and we will compare those checksums to make sure that the data has not been corrupted in flight or at rest when it is on the secondary on the cell. As a precursor to this, we are going to break out the checksum capabilities that is part of Geo today, and make it independent of Geo. And then we'll start to run that on GitLab.com. The checksum also surfaces integrity issues with the data. So for example, a good example is there is a database record for a file, but the file has been deleted. And this can happen for various reasons. There could be infrastructure changes, buckets were maybe deleted, or there was a bug in GitLab that feature deleted the file, however, did not delete the record. So we've seen this with Geo. As customers try to set up Geo, there have been some issues. Nothing that's leads to major problems, but it's a general cleanup that we want to to do that, will help us do that. So we'll run this ahead of time on .com and clean out any stale entries or orphan entries on the database side and on the file side. And then, as I mentioned, we will use Postgres is the key data that we need to replicate here that drives the org mover, and we will be validating whether logical replication, which is the leading technology we're looking at, will help us achieve this. Essentially, we want to move a subset of data from the source Postgres database to the database on the cell. And so logical replication allows us to do that, whereas what Geo uses today, which is streaming replication replicates the entire database. And this is not what we desire. We want to be able to move just the organization's Postgres SQL data onto the cell. And Postgres 16 has many optimizations that have improved the logical replication process. And in this milestone, what we will be doing is we'll be validating that this indeed helps us achieve what our requirements are for org mover. And then finally, the team will collectively try and make progress on documentation improvements. As mentioned in previous milestones, we're going to try and chip away at this. Lots of things have changed over time on Geo, and we have fallen a little bit behind on keeping the documentation updated. So there's a number of issues under this epic, and we'll tackle this iteratively over a number of milestones to try and improve our documentation. And lastly, we have a few miscellaneous items, predominantly bugs that we want to improve, fix rather, and so we'll be working on those. Thanks very much for watching, and I look forward to seeing you next time.